Okay, so in fourth and fifth grade, you did learn how to add and subtract fractions, but only with common denominators. For whatever reason, you don't add and subtract fractions too much in sixth grade, so we jump back into it with seventh grade. Now, we already learned how to, or reviewed how to add and subtract fractions when they have a common denominator. The denominator is the same. But what do I do if I have fractions where they don't have a common denominator? That's where I need to force them to have a common denominator, which we look at the denominators and we're going to look for what's called the least common multiple. So if I'm going to show you some examples, and we're going to look at this two different ways, but if I'm trying to find the least common multiple of 2 and 8, think about multiples being like if I take 2, 4, 6, 8, 10, 12, 14, and so on. And then 8 would be 8, 16, 24, 32. Look at my list. What number do they both have in common? Well, they both have 8 in common. Now, they may not be in the same positions, but they both have 8s in common. So my least common multiple for 2 and 8 would be 8. If I look at the same thing for 3 and 5, if I list them out, 3, 6, 9, 12, 15, 18. If I do the same thing for 5, 10, 15, 20, 25, what's the smallest number they have in common? Well, 15. So 15 would be my least common multiple. If I look at 3, I've got 8, 16, 24, 32, 40. 10 would be 10, 20, 30, 40, 50. Well, my least common multiple would be 40. That's the smallest number that they both go into. If I look at 4 and 9, 4 would be, I'm going to do it off to the side here. 4 would be 4, 8, 12, 16, 20, 24, 24, 28, 32. If I do 9, I've got 9, 18, 27, 36. And it's not until I get further that I see 36 is their least common multiple. Okay, 4, look, 6 and 21. So 6, 12, 18, 4, 24, 6, 12, 18, 24, 30, 36, 42. When I do 21, it would be 21, 42, and then 42 ends up being my least common multiple. If I do 9, I got 9, 18, 27, 4, 36, 5, 45. And then 15 would be 15, 30, 45. And so I see 45 would be my least common multiple. So it's a process, okay? And I'll show you two ways to do this. But if I look at number 1, if I'm adding and subtracting, but I don't have the same denominators, we're going to first determine the least common multiple of those denominators. We're going to convert each fraction to have the same denominator, and I'll show you how to do that. Then we can, if it's subtraction, I'm going to show you how we can deconstruct, so that way it saves us some time. And then add or subtract the numerators, keep the same denominators, simplify if needed. So if we look at number 1, okay, I need to look at the denominators. My denominators for number 1 are 9 and 3. They're not the same off the bat. So I need to make them the same. So what numbers do 9 and 3 both go into? Like if I listed them out, what would be the least common multiple? Well, 9 would be the least common multiple. So this one already has a denominator of 9, so yay, I don't have anything to do there. But 2/3, I need to have a least common multiple of, or common denominator of 9. Well, what do I need to multiply by 3 to get to 9? You would have to multiply by 3. So if I multiply the denominator by 3, I have to multiply the numerator by 3, so I get 6/9. Well, now I have a common denominator, so now I can add 11 plus 6 is 17, and I keep the denominator the same. Now I convert it to a mixed number. How many times does 9 go into 17? It goes into 17 once, that's 9, and 17 minus 9 is, 17 minus 9 is 8, and I have a remainder of 8 with 9 as the denominator, like we practiced the other day. Let's look at number 2. Common denominator of 4 and 17. Well, if you think about it, 4, 8, 4, 3 would be 12. Then we got 16. Then we got 20, 24, 28. So it's not until we get to 28 that 7 also goes into. So what do I need to multiply by 4 to get to 28? I have to multiply by 7. 3 times 7 is 21. So the new numerator for that fraction is 21 over 28. On the 9/7, what do I need to multiply by 7 to get to 28? I have to multiply by 4. Well, 9 times 4, what I do in the denominator, do in the numerator. 9 times 4 would be 36. Well, now I can add, because they have the same denominator. 21 plus 36 is 57 over 28. Well, how many times does 28 go into 57? 28 goes into 57 twice. Yep, it goes into it twice, and that equals 56. 56 is 1 away from 57, so it has a remainder of 57. And then 28 as the denominator. So a little bit of a doozy one on that one. Okay. Number 3, 6 and 12. What number can 6 and 12 both go into? Well, 12, because 6 times 2 is 12 and 12 times 1 is 12. So if I want to convert this first fraction to have 12, how many times do I multiply it by 6 to get to 12? I have to multiply by 2. If I multiply the denominator by 2, I have to multiply the numerator by 2. So I get 10 twelfths minus 7 twelfths, because this one already has a denominator of 12. And now I can subtract. 10 minus 7 is 3 over 12. And I can simplify 3 over 12 by dividing by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So my final answer is 1/4. Let's do that again. Number 4. 3 and 5. What numbers do 3 and 5 both go into? They both go into 15. Well, what do I need to multiply 3 by to get to 15? I have to multiply by 5. 2 times 5 is 10, so that's the numerator. What do I need to multiply by 5 to get to 15? I have to multiply by 3. So 5 times 3 is 15. That means 1 times 3 is 3. And now I can add. 10 plus 3 is 13, and I keep the denominator the same. So 13 over 15 is my final answer. Now let's throw in some mixed numbers. First things first, I want to leave the whole numbers the same. I know we did crazy C the other day, but I want to keep it very simple so we're not dealing with really, really large numbers. So let's just focus on 1/3 and 1/4. Well, what's the least common multiple of 3 and 4? What number do 3 and 4 both go into? They both go into 12. What do I need to multiply by 3 to get to 12? I have to multiply by 4. So 1 times 4 is 4. What do I need to multiply 4 by to get to 12? 3. So 1 times 3 is 3. Now I'm just going to bring down my whole numbers and the subtraction. Now, to see if I need to borrow, especially when we're talking about subtraction, do I need to borrow from the 7, or can I do 4 minus 3 and get a whole number? You can. So 4 minus 3 is 1, and I keep the denominators the same. 7 minus 1 is 6, and so my final answer is 6 and 1/12. Not too bad. Let's do that again. Again, even though, yes, we normally had to do crazy C, I'm going to keep my whole numbers the same, and I'm just going to look at 2/3 and 1/8. Well, what number do 3 and 8 both go into that would be the least common multiple? Well, 3 can be 3, 6, 9, 12, 15, 18, 21, 24. 24 would be my least common multiple because 8 goes into 24 as well. 3 times 8 is 24, so 2 times 8 is 16. 8 times 3 is 24, so 1 times 3 is 3. I'm just going to bring down my whole numbers, and now I'm going to add. 2 plus 6 is 8. 16 plus 3 is 19 over 24. I can't simplify 19 over 24 any further, so my answer is 8 and 19/24. Number 7, leave the mixed numbers alone. So I'm just going to focus on 1/4 and 2/5. Well, 1/4 and 2/5, they both have a denominator of 4, or one has 4 and one has 5. 4, 8, 12, 16, 20. Well, 25 can also go into 20. So 4 times 5 is 20. That means 1 times 5 is 5. 5 times 4 is 20. So 2 times 4 is 8. I'm going to bring down my whole numbers and the subtraction. Now pause. When I see subtraction, I have to see if I need to borrow. Well, so you see right here, can you do 5 minus 8 and get a nice whole number? No. So I need to borrow from 12 to add enough up here to subtract 8. So if I take 1 away from 12, makes it 11, I've added 20 pieces to my numerator. So 20 plus 5 is 25. So if you're not sure where that came from, think of each of these as a pie, okay? Like we talked about the other day. When I take away a whole, I have 20 pieces from that whole. That's where the 20 comes from. So, and then I'm adding that to 5 more pieces, so 25. Now, nothing happens over here. I'm just bringing that down. But I needed to take away from the whole because I need to be able to subtract 8. Well, now, can I subtract 8 from 25? I can. What's 11 minus 5? That's 6. 25 minus 8 is going to be, that's 5, 3. It's going to be 17, okay, over 20. And I can't simplify 17 over 20 any further, so there's my answer. Let's do that again. Again, it only applies to subtraction. Well, let's do the denominator first. 4 and 10, okay? 4 and 10. So 4, 8, 12, 16, 20. 20 goes into both 4 and 10, or 4 and 10 go into 20. 4 times 5 is 20, so 3 times 5 is 15. Bring down the 1. 10 times 2 is 20. 9 times 2 is 18. And then I check to see, do I need to borrow? Well, can you do 15 minus 18 and get a nice whole number? No. So I need to borrow from the 1. So there's 0 left there, but I'm going to add 20 pieces to 15. So 20 plus 15 is 35 over 20. I'm going to bring down that minus 3 and bring down the 18 over 20. 35 minus 18 ends up being, 35 minus 18 ends up being 25 minus 8, 20, and 3, 17. 17 over 20, okay, 35 minus 18 is 25, minus 8, 25 is 20, yeah, 17 over 20. Now here's a strange one. What, if anything, there's an invisible 0, if you will, in front of here, and 0 minus 3 is negative 3. So I end up with negative 3 and 17/20 for that one. Okay, so let's try some more. Again, anytime I see subtraction, I have to think about, do I need to borrow? Let's talk about 1/8 and 3/5 first. Sorry. 8 and 5. What numbers do both 8 and 5 go into? The smallest I can think of would be 40. Okay, 8 times 5 is 40, so 1 times 5 is 5. Bring down your 18. 5 times 8 is 40, so 3 times 5 is 20, or 3 times 8 is 24. Bring down that minus 4. Now, because I see subtraction, can you do 5 minus 24? You can't. So I'm going to borrow from the 18 and make it 17. But this time it's 40 pieces. So I'm going to add 40 to the 5 and make it 45. Then I'm going to bring down the right side. Okay. What's 45 minus 24 now? Now I can do the subtraction because I end up with 21 over 40 and 17 minus 4, which would be 13. And there's my answer. Addition's simpler, but we still have to do some math here. Got to have a common denominator. 9 and 12. So we got 9, 18, 27, 36, 45. Oh, wait, 36. 36 is my common denominator. 9 times 4 is 36, so 1 times 4 is 4. 12 times 3 is 36, so 11 times 3 is 33. Then I bring down that plus 4. Now, because it's addition, I don't have to worry about borrowing. 0 plus 4 is 4. 4 plus 3 is 37 over 36. But with addition, you might have improper fractions. So 37 over 36 is too large, or is bigger, so it's improper. 36 goes into 37 one time, so that adds 1 to the whole number. And then I have a remainder of 1 over 36. So 5 and 1, 36. Number 11, 8 and 6. 8, 16, 24, 24. 8 and 6 can both go into. 8 times 3 is 24, so 1 times 3 is 3. 6 times 4 is 24, so 1 times 4 is 4. I bring down the 1s and my plus sign. Again, I don't have to borrow when it's addition. 1 plus 1 is 2. 3 plus 4 is 7, and I keep the denominator the same. This time it's not improper, so my answer is done, and I don't need to simplify. Number 12, here comes another subtraction. First things first, common denominator. Well, 6 and 12 have a common denominator of 12. Now this one's already has a denominator of 12, so I'm going to bring it down. 6 times 2 is 12, so 1 times 2 is 2, and bring down the 1. Now, when it comes to subtraction, I have to make sure I can subtract my numerator and denominator. 2 minus 11, I can't do. So I'm going to borrow from the 1, but that makes it 12 more pieces I can add to the 2, so it's 14 over 12. Minus 1 and 11 twelfths. Now, 14 minus 11 is 3 twelfths, and 0 minus 1 would be negative 1. But because 3 twelfths can be simplified, negative 1 and 1/4, because 3 goes into both 12 and 3 for 1/4.